HCF of decimal fractions. So example is, first example, 1.2, 2.4 and 3.6. Okay, so these are decimal fractions. Now think that there is no point in between the numbers. If there had been no point, then the numbers were like this: 12, 24 and 36, right? If there was no point, then the numbers are like this: 12, 24 and 36. Now think that how we can convert 1.2 into 12, or 2.4 into 24, or 36 into 3.6 into 36. If we multiply all the fractions by 10, 1.2 into 10, it will become 12, 2.4 into 10, it will become 24, and 3.6 into 10, then it will become 36. So we have multiplied 10 to all numbers. Now solve these three numbers and find out the HCF of these numbers. So directly we can now say that 12 can be the HCF, because 12 can divide 24, 36 and 12 also. Therefore 12 is the HCF. Okay, or you can solve like this: 6. With the help of 6 we can divide all the numbers. So 2, 4 and 6. Again 2, 4 or 6 remain, so we can divide by 2, 1, 2 and 3. So now there is no number which can divide all these numbers. Therefore the common factor is 6 and 12. Therefore HCF is equal to multiplication of these common factors. So 6 into 12, 6 into 2 is equal to 12. So HCF is 12. But this is not our final answer, because 12 is the HCF of these numbers which we have changed. The original numbers were 1.2, 2.4 and 3.6. So what we have did to convert this number into natural number, we have multiplied by 10. Now reverse the process. We have multiplied by 10, now divide by 10. So the answer will be 1.2. What we have did here, we have to return that. Okay, we took 0.1 digit forward. In the easy way we can say that instead of multiplying, we can say that we have shifted 0.1 digit ahead. The point which was between 1 and 2, now it is after 2, then the number will become 12. Similarly, we have shifted the point 1 digit ahead. Here also we have shifted the point 1 digit ahead, and the number became 12, 24 and 36. Now we have to return the point which we have taken 1 digit forward. We have to take now the point 1 digit backward. Now there is no point. Okay, we cannot see any point there, but there is a point. 12 means 12.00 etc. Like, right? So we have to return this point backward by 1 digit. Here we shifted point by 1 digit. Now we have to shift it back by 1 digit. So answer will be 1.2. Right? So let's take another example. 0.3, 0.9 and 1.8. So what we have to do first? We have to shift the point forward. If we shift the point forward by 1 digit, here also by 1 digit and here also by 1 digit, then the numbers will be 3, 9, 03 means 3, 09 means 9 and here 18. So now we can solve the HCF of these three numbers. Highest common factor will be 3. Okay, so 1, 3 and 6. Now we cannot divide, therefore HCF is equal to 3. But HCF 3 is the answer of these three numbers. The original numbers were 0.3, 0.9 and 1.8. So what we have did here, we shifted the point by one digit. Now return that. So there is no point we can see, but there is a point. 3 means 3.00. Now shift the point backward. We have shifted here forward. Now shift the point backward. So number will be 0.3 means 0.3. 0.3 is our answer. Right? Okay. What if the point is different? After point there are different numbers, like the examples we have seen. In these two examples there is a single digit after the point. If there are two numbers or three numbers or different numbers after point, then what should we do? Let's take another example. 0.3, 0.1, 12.0 means 12 only, and 0.15, or we can erase this 0. Now after point there is one digit, after point there are two digits, and there is no point. So what should be done in such examples? So we have to decide where the digits are more after point. Where are the digits are more after the point? So here is one digit only, here is no digit, and here are two digits after point. Right? So where there are more numbers after point, we have to take the point as much as there are numbers ahead. Okay, so we have to shift this point by two digits, and in all the numbers we have to do the same. Okay, we cannot take it by only one digit, we have to take by two digits only. Okay, that's why we have checked where are the digits more after point. Right? So here are two digits after point, therefore we shifted the point two digit ahead. Here also we have to shift the point, which there is an invisible point. Okay, 12 means 12.0. So there was a point but it was invisible, so we have to shift it by two digit. And here also we have to shift this point by two digit. Okay, so now by shifting this number will be, so there is only one number and we have to shift by 2. So what should we do? We have to add another 0. Okay, so number will be 30. The point which was before 3 now it is after 0. So we have shifted the point 2 digit ahead. Right? Now here same case, we don't have any number. So what should we do? We have to add zeros and we have to shift the point 2 digit ahead. Therefore the number will be 1200 and at the last 15. Okay, now find out the HCF. Find out the HCF. Can we divide all the numbers by 15? The smallest number is 15. Can it be the HCF? Let's check. 15 can divide 30. Can 15 divide 120? 15 into 8, 120 and 0. Yes, 15 can divide 1200 and itself also. Therefore, HCF of these three numbers is 15. But this is not the final answer. This is the answer for these three numbers. Okay. So our correct answer will be, after shifting the point backward, we have shifted the point 2 digit ahead. Now we have to return that. So we have to return point which is invisible again. So 15 means 15.0. Okay. So we have to shift this point backward by 2 digit, because here we shifted point ahead by 2 digit. Now we have to return back it by 2 digit. So answer will be, after shifting 1 2, the point will come here before 1. So the answer will be 0.15. 0.15. Okay. So in this way we can solve the HCF of natural numbers and HCF of decimal fractions. Okay. So in the next video we will discuss about LCM of natural numbers, LCM of fractions, and then we will discuss about HCF and LCM of simple fractions like 1/2, 2/3, etc. So till then, keep practicing. Okay, thank you.